So for part C, the calculate the concentration of potassium oxalate solution used in the titration. So the oxalate is the K2C2O4, so this one here. But before you start the calculation, you need to get the overall redox equation. So you need to do what you did at higher or nat 5 and balance these out. So you need to times this top one by 5 and times this one by 2. So that means you have 5 moles of the oxalate and 2 moles of permanganate. So because they're the only two chemicals that are reacting, you don't really actually need to multiply everything else as long as you get the mole ratio of those. So we've got permanganate that we're titrating with, and then the oxalate that we're trying to calculate the concentration of. And we've now discovered it's a 2:5 ratio in that direction. So we've got 25 centimetre cubed sample of oxalate. So that is a volume of 0.025 litres if you divide it by 1,000. And then it's heated to 80 degrees and titrated with a standard solution of 0.02 moles per litre potassium permanganate. So that's a concentration of permanganate, moles per litre. And then the end point was reached when 22.5 centimetre cubed of permanganate solution had been added. So that's our volume of permanganate. So again, divide that by 1,000, so that'd be 0.0225 litres. So to start off with, all you can calculate is moles of permanganate. We're trying to work out the concentration of the oxalate. So N equals C times V. So if you do that, 0.02 times 0.0225, that gives you 4.5 times 10 to the minus 4. So then we've got a 2:5 ratio, so we need to divide by 2 and times by 5. So that gives you 1.125 times 10 to the minus 3. And then C is equal to N over V. So if you do the number of moles, you've just calculated, divided by 0.025. That should give you a concentration of 0.045 moles per litre. And that's the answer.